So, welcome to today's episode of Insights Unplugged. This is actually number 9. I can't wait till I get to number 10, and then these numbers will keep moving. AI in the lives of extraordinary people. We're thrilled to delve into the groundbreaking work of Julianna Oláh, a trailblazing co founder and CTO of Psyrin, at the forefront of AI and mental health innovation. Juliana's expertise in NLP and speech analysis, combined with her dedication to transforming care for severe mental illness, is reshaping clinical pathways and advancing the field. Juliana, it's such an honor to have you here with us today. How are you and where are you in the world?
Hi, I'm doing fine, thank you. And now
London town. And were you traveling recently as well?
we attended the conference in Paris, and we have to travel a lot now because of the company. But usually I base in London.
Wonderful. Well, we look forward to learning more and talking about that company. Can you tell us a bit about yourself and the role that you have at Siren?
Yeah, so my background is originally in psychology, and then I started doing a PhD at King's College London in AI applied in mental health, especially using speech to detect the early symptoms of schizophrenia and bipolar disorder. And based on this research, I just found some really interesting findings and I started to learning more about this technology. And then I wanted to apply to real life and make a real impact. So I co-founded a company, Sidin, with Ed, my CEO, and Rahim, my COO there. And we started it 2 years ago around. And my role is as a co-founder, you can imagine the beginning, it's pretty versatile. So you do almost everything. But nowadays, I'm usually responsible for innovation, research, development. Basically, the IP of the company is mostly under me, and the models that we use, and basically the AI part that we use for our product and softwares is under me.
What inspired you to focus on the intersection of AI and mental health?
I think the mental health part is a little bit easier to report. So I'm coming from a background and I had lost few loved ones because of really serious mental health issues and in fact, it had a big impact on me and affected my personal life quite deeply. So I'm personally really lucky to not having any serious mental disorders, but I always felt that, how can I help the people around me who suffered, and it inspired me to somehow delve into the knowledge about it. And the AI part is, some people say it's a little bit unconventional to merge the two. It started that at uni, most of the psychologists said that they are not good at stats because they just refuse to learn math. But I'm personally pretty open to it and I enjoyed it. And I just needed money to sustain myself financially during my bachelor's. So I started working as a research assistant and everyone was putting stat on me. And because of that, I had to learn how to code to speed up my workflow, and it just led into more complex modeling and then led into AI. And then by the time when I started my PhD, I was pretty invested in, especially natural language processing. I just love language because of my love for literature, and I just find it really interesting how you can computerize it. And then when I found this research topic, like early changes in language use and mistakes and articulations can signal the later development of a mental disorder, I was like, oh wow, that's amazing. This is for me.
Can you share with us your journey in the field of AI and mental health leading up to your role at Siren? So just dive deeper into that.
So basically, I'm in London starting my PhD and in the second year of my PhD, and I saw that I learned the basics and I got a really big conviction that speech and speech-based biomarkers can be a play-changing element in mental health and mental health assessment. But I also noticed that in academia, everything is pretty slow. And I want to actually apply my models and my results in real life settings and in clinics. And I realized that it's impossible to do by the end of my PhD, but even after my PhD, I have to go for a postdoc. And then until I can actually start my own research, it's ages and I'm really impatient. And at the same time, I noticed that academia is not really fitting to my personality. I'm a little bit more rebellious and more vibrant than most of the people who choose to stick to the academic lifestyle. So I was thinking about some intersections. And I had a company in Hungary which works with online mental health services. So I had some experience in entrepreneurship and I also worked for other mental health startup in the past. So I knew that I like it and I knew that I really like working in teams. So I just decided that maybe I should just start a company, and I was really invested in research. I knew that I want to do a deep company in mental health, just make something that's innovation led and research heavy. And I went to a Christmas party at Entrepreneur First to find, basically, I was interested in joining to the program, which is basically an international program right now to match people to start companies together. And I wanted to figure out the program on its own and find a co-founder in the program. And then I met Ed, one of my co-founder there, and we went out for coffee later and we realized that, wow, we actually doing PhD in the same department and we are interested in the same mission. And from that, it was pretty easy. We applied for a pitch competition because we wanted to test out whether we can work together well. And by the time we won this pitch competition, I was pretty sure that I want to work with him. He was also pretty sure that he wants to work with me, and we can actually skip this whole entrepreneur first program because we already found each other. And at this pitch competition, someone was in the audience, Rahim, my other co-founder, who just approached us after it and told like, hey, I'm a doctor and I did my dissertation in non-imaging biomarkers and schizophrenia, which is one of the several mental illness that we actually focus on. And he was really interested in speech based on his research. And we just started working together. And it was pretty obvious from the beginning that I will work on the technology side, given that I have a PhD in it. So that will be my expertise. And I was also interested to learn about it more. And Ed is really someone who understands research deeply, but he really does not like spending time in front of a computer and in front of numbers, but rather appreciate talking to people. So it was just a good fit. And Rahim was interested in operations, clinical implication, his expertise. So it was more like something what I brought to the team, but I think I'm good at, but also just in relation to my other team members, how can I contribute the most?
Wonderful. And then your research at King's College London, and how did that inform your work at CERN?
Well, it's inspired from two elements. One is most of my theoretical knowledge has been gained during my PhD. Actually, I'm just submitting it now, and I still learn because I did it part time to the startup just to finish it. And the other is that just learning about the landscape and learning about clinical practice was informative because I know where are the biggest bottlenecks in the workflows. And it was also informative to understand how we can collaborate with academia effectively and what good science look like. But it was also informative from the perspective of that, wow, it just think in academia maybe makes this technology applied in the reality in 20, 30 years. And I want it to happen quicker. So it was also a pull and a push.
And CERN aims to transform care pathways for psychosis using machine learning and speech analysis. Can you explain how your software achieves this?
Yes. So just a big context about maybe some of the listeners do not know a lot about psychosis and what it is. So it falls under serious mental illness. Serious mental illnesses are disorders which require clinical care. So unlike, for example, some forms of anxiety and depression cannot be treated just with telehealth option, and it cannot be treated, for example, just with help of a psychologist. You have to go to a psychiatrist, get some medication. Really often you also have to get some inpatient care. And when you have psychosis, you basically lose touch with reality. So you will have delusions, you will have hallucinations, and you will have something that we call thought disorder, which means that you have difficulties organizing your thoughts, and sometimes it's really difficult to understand what you want to say. And our technology works in a way that it fits into the current assessment practices that we produce. So now it's really difficult to diagnose these disorders. People go for in-person interviews, which are subjective and time intense. But also there are some services which are designed to prevent this disorder because the idea is that before this whole psychiatric episode happens, you will have subtle attenuated signs and subtle forms of the symptoms. And if we can catch it early, we can delay this episode, prevent this episode, and improve the prognosis. So, for example, like cancer, if you notice it earlier, you can have way better treatment options and way better outcome. But now, in order to detect it early, you have to go for really specialized services. Not many people know about them, and the assessment take months in best case, and also really subjective, many interviews, and it's not accurate. So we don't really know who we should treat. And this is where speech comes in. So once we do that, we ask patients to record their speech in response to standardized prompt. Now we ask 5 minutes of the speech, we analyze it. We now analyze it from two angles. One angle is articulation and acoustic changes, and the other angle is linguistic change. So based on the vocal parameters and based on the text that we produce, so we create an automated transcription of what they say. And then when we analyze the language and both the articulation according to different parameters, now 240 parameters, we feed them into a machine learning model. We learn ensemble learning techniques right now, and it gives different readouts. And these readouts can be like your diagnostic criteria. So do you have given disorders or not? Do you have some level of neurodiversity or not? But it can be also, for example, a prediction of a symptom scale. So this is what we do right now. In the future, we also want to apply it to predict whether someone will relapse. So we can monitor patients who have been already diagnosed and have the disorder and prevent them from this horrible condition when they relapse and they have to go back to hospital, like basically fall out of their life for months. So that's something that we really want to avoid too, and patients want to avoid. And it's also really expensive. So for the healthcare system. And either in the future, we also would like to inform treatment plans and outputs. And why it works, why speech works, is because one element are the neural changes that happen in your brain when you get these disorders are reflected in your speech. And for example, this disorder that I just mentioned at the beginning is really well reflected in what you say. For example, the syntactic complexity of your language. But also these disorders are often accompanied by emotional changes, for example, flattened effect. And from your voice, from your tone, you can also understand whether someone, the emotional state of someone. And that can also, now you can hear that I'm smiling because I'm super excited about it. But if I have schizophrenia, it's likely that I will talk in tone like this and naturally changing my voice. And that's something that you can analyze automatically. And these are symptoms that we capture. And all of this articulation is not just connected to your emotions, but also the muscle functions and the articulatory muscle moves that also change in connection to the brain changes. And finally, what I love in speech that is not just connected to neural changes, but if you think about that, mental disorders are also mental, connected to what you say and what you think. So your thinking processes, which are often also a little bit changed and altered, usually not in the best way in these conditions. And by what you say, we can also break it down and detect it. So that was a really, really long summary of it.
No, and you explained it so beautifully because, there are so many different elements of it. I think data is really obviously fundamentally at the core of all of that. So a question that's actually not here and I haven't sent you, but as far as this data, it takes a long time to keep building that data, right? To be able to start recognizing. So how long have you been doing this? And I guess you're never satisfied because you're constantly going to be updating it. But are you already rolling this out? One of my questions here is, in clinical care. So how are you finding these patients? If you can kind of answer that two part as well, that'd be great.
Yeah, so importantly, our technology works remotely. So we work with data that's speech data that people record on their own devices, usually at home. And it's good because of clinical care. You can reach people who otherwise not really able to come to the clinic. But also it's good because I could collect speech data from the general population via different platforms. And that's what we did in the past, that we collected a lot of data from people who have been diagnosed with different conditions and people who have just filled out questionnaires. And according to questionnaires, it suggested they have some prodromal symptoms of the disorders. And now we also started to some research study at clinics, and we have a product that helps clinics specialize in the prevention of schizophrenia and bipolar and psychotic symptoms of bipolar disorder. So prevent psychosis in the US. And we will have our first launch in May, which is pretty exciting. And what we specifically have this clinic is that we show different speech markers. And we know that, for example, if this speech marker is more than 60, so they are likely that you are depressed. If speech marker is more than 40, then it's likely that this person will develop this disorder later. For example, psychosis. And if this score is more than 80, then this person is really, really anxious. And they will read these markers and it will speed up their clinical decision-making process and apply for screening. It's not replacing the whole workflow, which would be our aim in the future. So clinicians can actually treat people, provide psychotherapy, provide better medication. But if you make the workflow quicker and more accurate, that's our hope. And we also want to launch a public product when people can, for free, just to test whether they have different neurodiversities and whether they have a serious mental illness. It's mostly for direct purposes. So we want to figure out whether it works, whether people like it. But we also hope that it can be useful, and it will be out in August.
I think it's wonderful because, we all go through so many things as humans and pandemics, for example, and it's always just so alienated and so far, right? From going to be diagnosed with something to actually just going, oh, let me see how happy I am today, or whatever this app or whatever you're going to supply people. So I love it. Let's move into now side projects and interests. Apart from your work at Siren, you're also involved in side projects related to health equity, gender equality, and early intervention in mental health. Can you tell us a little more about these projects, please?
Yeah. So for me, like, equity to access to care is really important. Just an example is that I'm from Hungary. In Hungary, there is no preventative care for serious mental illness at all. While if you are in the US, they are, they're not a lot and trying to help them to scale up, but they're at least available services. They also know that people, and there are a lot of research on it, people who lives in more rural places and also who are having lower social economic status, just way worse access to health. And it's important part of our product. And that's one of my hope and mission with it is that to actually help people to get access way quicker because they can have this remote assessment. And importantly, in subjective assessment and interview, we know that there is a lot of bias towards populations who are vulnerable anyhow, people who are sexual minorities, ethnic minorities. And that's the beauty of speech is that if it's more objective, therefore we can reduce this bias and we constantly monitor product on is it perform as well with people who are coming from a white background, with people who are having a background, for example, is it the same with people whose first language is English or not? So that's something that's embedded in the mission of Siren. Also, I find it super important to talk people about what are mental illnesses. I always try to be included in psychoeducation projects. I write blogs, most of them in Hungarian, and I also find it important to work in the tech field specifically to empower women because there are not many women in startups, especially not in tech startups. And I try to mentor people, and also I have been mentored by others. So it's more via mentoring and then just raising awareness. This hey, we cannot, our fifth employee must be a woman.
Well, you're definitely a great inspiration for all, not just female as well. And wrapping up now, what do you envision for the future of AI in mental health and what challenges do you anticipate?
Think one challenge is definitely making AI accepted because it has to be accepted by doctors and it had to be accepted by patients. And I see a really big scarcity of research that focus on the patient. So, for example, someone who has schizophrenia often have paranoid thoughts. If I monitor the speech of this person, well, will I increase this paranoia or not? So you have to do it really gently and consciously about their symptoms and their needs. And also, they often don't have access to technology as much. So you try to work around problems. And it's way more than a good UX design. You have to consider the patient from the very beginning of what you develop in terms of the product. And I think that's one of the biggest challenge. The other is just you have to develop models that are just basically equally good for everyone. So in order to increase and reach acceptability, you have to be actually more sensitive socially because doctors will ask questions like, what type of data your models are trained on and what's your accuracy in different demographic groups. You have to answer this. The other is that because of regulations, to launch any product takes a lot of time. So now it's a challenge to create protocols, both in the EU, but both in the US, that regulatory agencies, institutions can refer to. And there is not so many practical right now. And what I see as change, I think AI will be the part of mental health care. And I could group it into two big roads. One is to replace flows, for example, replace screening, potentially some diagnosis. And I think sometimes it cannot replace a workflow. for example, in terms of treatment, but it can make it more accurate and more scalable. So, for example, you can provide therapy, like one-to-one therapy sessions, and in the meantime, or on every day, people, for example, can chat with a mental health chatbot to just keep up their mood, for example, or just report their symptoms. Or in terms of, for example, medication treatment, it cannot replace the whole workflow because I think you need a doctor just to create drugs, but also the doctor can take personal element into account, like your lifestyle preferences. You can use an AI that just shows, like, according to your biological data, that would be the best treatment. Maybe it's not the best treatment for this person because we're not just biological data, but that's a consideration. So it could replace whole workflows. And I think in other cases, it can make other workflows more efficient, more accurate.
And how important do you think that interdisciplinary collaboration is advancing in mental health technology?
I think it's crucial because you deal with people and you always deal with people, but in mental health, you deal with people who are really vulnerable. And also you deal with people who you have to treat their mind somehow. So you have to work with them and you have to work with also clinicians. And I see many research is filled with wonderful models that perform amazingly on a really small subset of data. And when you show the results to clinicians or to show it even just for me, who is a psychologist, I say, it's cool, but takes 10 seconds of my workflow. Like, why shall I apply an AI for it? And there are no AI solutions for problems that actually takes hours of my time. And I think you have to work from the really beginning to define outcomes really well together in an interdisciplinary effort. And I not just mean as an outcome of diagnostic label, but also in terms of an outcome of, for example, you want to train a model that offer treatment, medication treatment for depression. And do you train the model on the labels of symptom change, or do you train the model on, for example, satisfaction with life? And that's something that patients usually want. They want to train the model on functioning and how happy they are. They don't care as much about purely the symptoms. They might have some hallucinations, but they rather be happy and able to go to work than getting a drug that just erase all of the symptoms, but also sedate them to the level that they cannot. And this is why it's really important to work in the disciplinary, because if you just pick up some random label, you train your model for a half year on labels that fundamentally broken or not relevant for the patients or the caregivers, then what's the point? So I think it's important to start and iterate together from the really beginning.
Yeah, to have all of those just different areas of the disease, I guess, segregated. And the more and more data that you have, the more and more solidified it will be and easier to be able to diagnose, I guess. And my God, so fascinating. Thank you so much for diving into the brain, into the emotion, and obviously all wrapped up with AI, machine learning. It's incredible. Your pioneering insights and experiences in AI and mental health really offer invaluable lessons in innovation and the potential for technology to improve lives. I'm just completely passionate about AI and healthcare, and mental healthcare is so fundamentally important. Thank you so much. Thanks to our listeners. We hope that this sparks curiosity and drives forward thinking in the realms of mental health and technology. Until next time, if you would like to obviously follow Julianna as well, I'm sure she would love to hear from you in LinkedIn. Thanks so much, Julianna, and everybody for listening. Bye for now.
Thank you very much.